Hi, welcome back to Foundations Python. My name is Dennis. We're going to learn about creating modularity with functions. So today's learning objectives include understanding function constructs, imports and exports, and we're going to be able to create an exportable library to re-import in a different application. You also want to analyze your function and recreate commonly used functions with your own methods. Let's get started. So functions are what? Remember what we talked about early on in the beginning of the Python modules. Functions include taking something in and spitting something back out. Keep that in mind as we go through. So what qualifies as a good function, right? Functions are essentially microservices. And microservices are really just a bunch of APIs or single use or very robust functions that are provided over a network or in the internet itself. Take, for instance, a monolithic application. We have an application that does all in one, and we want to break it down into multiple APIs instead, so we can use different APIs inside new programs instead of being only contained in one program. Right? Those are microservices architectures. What qualifies to make something a function? Well, is the code you're evaluating to convert into a function can it be reused? Right? If it's reused and repeatable, that qualifies for something good to be a function. Right? I wouldn't want to repeat Dennis equals Dennis or Dennis equals Dennis makes true all the time because it's not really repeatable and it's not dynamic. Who is the target audience? What is the function? Is it internal or external? How do we scale that function? Should it become an API to begin with? Should it be a local API or qualify as a fully blown microservice API with RESTful requirements? Does your function need network connectivity? Right? Maybe you need to containerize it and expose it as an API. And does your function depend on other packages, virtual environments, resolving dependencies? All that has to be put in scope on qualifying what should be a function to begin with. First and foremost, there's functions without returns. Now, a lot of students have trouble, well, how do I create my first function? Let's slow down and think about this carefully. I said Dennis equals Dennis is not a good choice, but maybe Dennis with a different name and result, counting my name length. This comment section right here is getting it to work. So I always encourage students, get your code to work first without the function, and then wrap the function around your code. So notice I don't have any indentation requirements right here. I'm just taking user input, getting the result of the length, which is 6, which is Dennis. If I wanted to make this a repeatable item, right, instead of saying Dennis, what if I took my input to be something else and always measure it? So if I took my input each time and it wasn't Dennis, it would capture something else. So I want to create the name length of a function instead of just using my name by itself. I could be my name, could be foobar if that's your name for whatever reason. And so I'm creating my definition of my function right here. Notice the prefix right here, def, plus the function name, any input I expect from it, and a colon, and a follow by what? My first indentation right here. Create the result, and then print the result. Now, I'm not returning anything, okay? I'm not returning any calculation value. I'm just printing the standard out. It's a huge difference. And we'll see this in a second. Note this. I'm saying the length of Dennis as a function, I'm calling it using the function as the input of Dennis. Of course, it would say 3 if it was saying foo. Now, print my result. Oh, there's nothing in there because I didn't return a result. How do we return an actual result to make sure it goes into a variable? So if I said result should be 6, right? Don't just print it standard out. Give me the actual number 6 so I can do something else with that. Introducing functions with returns. Now, our old code is right here. Let's forget about that for a second. Now, here's our new code. I have the return keyword saying return my result of whatever the calculation is. And now, right, if I set my function of the name length Dennis again to the output of result, result should now be an integer of 6. That's all there is to it. The other thing that we have to keep in mind is driver statements. And driver statements are also called dunder main statements inside Python. Let's take a look at what that means. Here I have multiple functions. We have my name length function that we saw earlier, a useless function that is nothing but print stuff. And then we have my main function, my main page. And now I call my useless function as well as my name length function and print the variable. My driver code, however, because if my main function is based on other functions calling up here, it won't actually do anything until I call main by itself. So if I actually took this out, so let's take this back here in consideration. If I actually took this out of my code, nothing would happen. I'm just defining my functions, but I'm never calling it. So this will actually nest and call these other functions up here recursive. To import other functions, we actually have a requirement. Now, if I imported a sample application or a sample module, right? It's actually called sample.py inside the file system. And the reason why we can able to call that, even though it says py, into my main statement is because sample.py has this at the bottom. Right? So sample.py has this. It's called the dunder main statement. The dunder main statement basically says, hey, if I'm being called externally, don't call main. Just let someone call me from a set of classes of functions, or if I'm executing as myself, then call main. So basically saying, hey, don't actually utilize main as a driver unless I'm actually a sample.py being directly executed. So in this case, I'm importing sample.py. I'm saying, hey, I went back. Let's go back to our example. This nameLane function is inside sample.py now. Okay. Going forward, if I put this at the bottom, right? If I put this at the bottom of sample.py, I can now import it inside my other Python applications. Pretty cool. Now, keep in mind the prefix.py is the actual model name. And it has to be in a path that the Python 3 or your Python main code can find it, which is usually the same folder if you want, or /library. That's it for functions. Let's take a quick break and do a quick demo as well. We'll see you back. Come on, man.